Okay, hit the right button. Okay, so we are going to talk about average value today. We're going to do this lesson together. And then the next lesson, I have the video recording of me doing it live in class last year. Sometimes there's value in that, so you can sometimes hear me answering other students' questions in case you had the same ones. It isn't broken up into short words, so I'm sorry about that. But it's better than not having anything at all, I figured. So, good morning, Brianna. So that way you might be able to fast forward through parts, because if there's big gaps of me not talking and you have it written down, you can fast forward through that part. Okay. All right. And you're not doing the whole thing. It's a pretty long, the next one, the 8.1 is kind of a long lesson. It kind of brings together all the word kind of type problems, okay, of both integration and derivatives. It's going to revisit some of that stuff. All right, we're going to talk about topic 8.1. We're going to find the average value of a function on an interval. And I know it seems like we're jumping from one thing to the next. Our goal on in these 2 units is to apply integrals. And again, I'm trying to crunch it all in before we are actually back on campus. That's my goal. So when we're back on campus, we are into AP prep mode. So we can get ready for that AP test and get you all to pass, okay? So the essential question is going to be, how do you find the average value of a function? So how do you find the average value of a function? And this one, just, we are on page 247. Okay, and then our I can statement is I can determine the average value of a function using definite integrals That's it, integrals. I can determine the average value of a function using definite integrals. Ooh, not that one. All right, so our formula for average value, or our setup for average value, and I didn't give you the big old long theorems. We're just going to put this out in the left-hand column. I've kind of blended a couple different people's note styles together here. So it's 1 over b minus a from a to b of f of x dx. That's what average value is. So the difference, so there's another word, average, that we have. We also have average rate of change. Average rate of change means slope. And we're going to talk about that again in the last part of the lesson, just to bring it back, because it's good to revisit it. Average value, you will see the word average, and any other word with the word average means you're doing an average value problem. There will also be an integral in there, or there'll be an interval in there somewhere usually that indicates average value. Or you're doing an integration of some kind. And basically what it means is you're taking the average of whatever all the little rectangles you were adding up. Okay, in theory, that's what we're doing when we integrate, is we add up all the rectangles under the curve. So you're averaging those out. That's what you're doing. So the average value of a function gives the average height of the graph, or in a word problem, the average, whatever the words of the equation are. So average, I think we're going to run across one in here. The average number of, hello, Hector. The average number of people allowed in the classroom. That could be one of our problems, right? All right, we're going to come back to the thing that has word problems. We're just going to do the calculation a couple of times here. I did not pull out my calculator yet. So if you have not gotten your graphing calculator out or in a while, find it. When it comes time for school, and those of you that are returning, please bring those with you every day because you don't know when we're going to use them. I will have a few, but we have to clean them in between. So if you bring your own, then you get to do your own, okay? And then make sure for AP testing, you bring it. You have to have it, okay? So if you check that out, bring it with you, make sure it's charged, okay? And the upside is if you have, I don't know if there's any other AP testing that has, if you're, I don't think any of you guys are in stats, but if there's any other AP testing that has a calculator, you can use that one. Okay, sorry, I'm letting it load so that we can do this all together. All right, here we go. So the average value of f of x equals sine x on the interval is just going to keep giving me junk here. All right. Find the average value of f of x equals sine x on the interval of 1/3 calculator permitted. So literally all I am doing is plugging this, or I was writing out the formula for average value and putting it in, okay? So you guys tell me in the chat, what's my b value? What do you think the b value is? All right, awesome. We're paying attention. Good job. All right, so we've got 1/3 minus 1, right? That's 3 minus 1. And then we go from 1 to 3 for our bounds. And then we're going to put this sine x dx in. If we were actually we were doing this on the AP test and it was a calculator problem, we could actually write f of x instead of sine x and we would still get the problem correct. And the upside of doing that is you're less likely to write it down wrong. All right, literally from here, I'm going to use my calculator, okay? If I was doing this on the AP test and there was a lot more to the problem, I would probably put it, I'd probably do the, whatchamacallit, I'd probably put that sine x into f of x if there was it was the free response over multiple pieces. It's not, so I'm just going to type it in the way it looks, okay? Maybe, yeah. So I'm on my calculator page, it's not escaping. Okay, I'm in my scratch pad, I'm going to go to my calculator page. Okay, and then I'm going to hit a control divide. We're going to pretend I don't know how to subtract. So I'm going to go 1/3 minus 1. If you know how to subtract in your head, you're more than welcome to do that. We're going to pretend I don't, so I get the answer completely right. All right. In order to, and you're going to want to write these words down, okay, somewhere in the left-hand side of your notes, okay? To integrate, okay, just off of this page, shift plus. So that was shift plus. So write that down in the left-hand column of your notes, shift plus. And then I'm just going to type 1 to 3. I could enter a function in here if I wanted to. Okay, I'm not going to because I'm just going to type sine x. So I could, that's where I could do the var f1 of x thing. I'm going to go trig sine. And notice it forces parentheses, x, and then dx. And then hit enter, we're going to get a nice decimal point. All right, so 0.765 is where we would go. And remember, we are allowed to just chop it off. We don't have to round. All right, so 0.765. And I'm also looking at my notes. Other ways that this could be stated over here is they could give us an interval like this. They could also say x equals 1 to x equals 3, something like that. Okay, so there's a lot of different ways that you can say it. Yeah, go ahead, Robert.
How do you put sine again on the calculator?
All right, so you hit this little button over here. See where my blue arrow is? It says trig.
Mm-hmm.
And then
okay, I see it. Thank you.
You don't ever type the words, so try to type the word sine and it won't work. So on the trig functions, on the log functions, on the E, you want to always use the buttons that are designed for them. Okay?
Okay. Thank you.
You're welcome, kiddo. Thank you for asking questions. All right, I'm going to keep going. So we got to do example 2, find the average value. And this time it says it's non-calculator, so we're going to do this one by hand. Okay. It's good practice, though. We got to practice the doing it by hand every so often. Okay. So we haven't done a definite integral in a while. So find the average value of f of x equals 2 minus 4x on the interval from 2 to 6. Okay. So when I see the word average value, what do we have to put out in front? Can you guys tell me, what do we put out in front when we see the words average value? What do we have to put out in front? I'm going to slide this back up here. So what do I put out in front when I see the words average value? Just in general is fine. Going to give you a little bit of a hint because I'm not seeing anybody. Okay. What do we put out in front when we see the words average value? Help me out. Make me know you're paying attention. There we go. Now we got one. Okay. So when I say that, when we see average value, this is typically the way people remember is this is the thing with the 1 over b minus a out front. Okay. I don't know if there's any other better way to remember it, but that's what I typically had happen in the past. All right, so we're going to do 1 over our b and our a are the 6 and the 2, so 6 minus 2, and then we're going to go from 2 to 6, and then we're just going to integrate 2 minus 4x dx. And this is like super basic integration. I know out in front I'm going to get a 1/4. When we integrate the 2, we get 2x. When we integrate the 4, we get negative 4x squared over 2, which is going to reduce to a 2. We're going to calculate this from 2 to 6. All right, definite integral. So we've got 1/4. I am going to write this as 2 times 6 minus 2 times 6 squared. And then I subtract, and I've got another 1/4 times. I always carry my 1/4 with, or whatever the coefficient is, I carry it in front. Some teachers don't do that. They do an extra set of parentheses. 2 times 2 minus 2 times 2 squared. Now, technically on the AP test, we stop. If this was for your response, we stop. I know it's very uncomfortable for us because we like to solve it all the way and get a numerical answer, but open-ended for response questions, we stop there. I'm going to pretend it's multiple choice because I know we need the practice going all the way down. So we're going to keep going with it. All right, so here we've got 1/4. Let's see, 2 times 6 is 12. And then 6 squared is 36 minus times 2 is 72. Minus 1/4 times. 2 times 2 is 4. Minus 2 squared is 4 times 2 is 8. So let's see, 1/4 times negative 60 minus 1/4 times negative 4. So we end up with negative 15 plus 1, which is negative 14. So we've seen one with the calculator, one without. We know it could be done either way. I think we have one later on. We typically will see this based off of a table. A lot of times they'll couple this with a trapezoid or a Riemann sum of some kind on the AP test. So we will definitely, maybe not in today's lesson, but we'll definitely see some of those as we go through AP review. Okay. All right, we're going to go back to the left-hand column. You guys ready for that? Back to the left-hand column. So in the word problems, it asks for average. So if it asks for average, find the average value if the question matches the words of the equation. Then we find the average rate of change. So when we see the words average rate of change, can you tell me in the chat, what are we really calculating there when we see the words average rate of change? Oh, good. We haven't forgotten this. You guys are awesome. We are calculating the slope. Exactly. And typically it means we're calculating the slope with the slope formula versus the derivative, okay? All right, good job, everybody. All right, so the word, if you need to add the word rate, okay, to the words of the equation, that says the words of the equation to match the question. So hint, they will try to confuse you by saying find the average rate, but you are not necessarily finding the average rate. So sometimes they give you stuff that's confusing. Hopefully we'll get it so it's not. But usually on an average rate of change, they literally say find the average rate of change, okay? On an average value, they don't say, they just say the word average and then some words, okay? All right, so let's look at what one of these are like. This apparently was very creative when I wrote this problem. So goldfish crackers are disappearing from the Ballard house at a rate given by t equals 7t plus 100 over t plus 2. We have a pantry cupboard where we keep like a big cereal box thing of goldfish crackers and Cheez-Its. There's a Cheez-Its one too. And the two little guys get in there and go after the crackers when they get hungry. They don't tell us they're hungry. They just fend for themselves. It's pretty funny. The other day, though, Mikey took the Cheez-Its and he smashed them all up into crumbs, and then they were taking turns licking them out of the bowl. You gotta love the ingenuity of 2- and 4-year-olds. All right, find the average. It was a mess. I was very upset. Find the average rate of goldfish are disappearing from the Ballard household from t equals 0 to 9 hours. Okay, so average rate of goldfish, okay? So in this case, because this here is, it doesn't say rate of change, it says rate of goldfish are disappearing, and it matches what was going on here, that's an average value problem, okay? So we're going to go 1 over b minus a, which is going to be 9 minus 0, and then the integral. And because this is, there's a typo in here. What happened? Look at this. There should be a G right here. G of t, okay, for goldfish. This is a calculator problem. I know it doesn't say it, but this one is a calculator problem. So I'm not going to write this actually out. I'm going to say G of t dt. And then we're going to put it into our calculators. Oh, I got to go from 0 to 9. Okay, this time let's practice putting this into our graph, into our function. Okay. Oh no. Hang on. All right, I may have to run to the front door here in a minute, so we will see. Okay, the pool's getting redone this week, and they just pulled up, and my husband's not home. Gotta love it. They're gonna love the outfit too. I went with the leggings on the bottom today. All right, Doc B. Okay, so here we go. We'll do the best we can here. All right, so we've got set. Notice it's in T's, right? I notice my graph is in X's. So I can't put T's in the calculator. We're going to use X's. So we're going to convert everything to X's when we put it in. So I'm going to go 7x, and I put this into F1, okay? Plus, I'm going to do a control divide, 100 over 2x plus 2. And I'm going to hit enter. And notice I see nothing. It's still there though. If I hit the tab key, it's just because it's not in the domain that we have our graph set. All right. All right. The next thing I'm going to do is I'm going to come over here and I'm going to do control divide and then 1 and then 9 minus 0, which I could do in my head. The bell's going to ring in just a second. And then control, oh no, sorry, shift plus, oh, that's not what I wanted. I hit the control first. Shift plus Then it goes 0 to 9. Okay. And then it's going to be var f1 of x dx. And I don't know why I got a capital there. And I'm going to hit enter. Okay. Write that down. I'll be back in like 10 seconds. Okay.
Hello. I'm your new teacher. This is entertaining.
Are you entertaining everyone?
Yeah.
All right.
I sound much better than that.
Is Ellie better than math class? It's a
Yeah.
wonderful. We just did it. We're doing a problem about goldfish crackers, though. Ellie says that's the snack that smiles back.
I was
All
playing
right.
Among Us and someone was orange and it had a name of goldfish and they just put in the chat.
You're playing Among Us instead of doing class?
No, this
Okay.
was like a month ago.
All right. Robert, you're exactly right. Good job, Robert. So 50.441. Did I get the same answer? Is that where yeah, we got the same answer. Nice job, everybody. Okay. Let's keep going. Okay. Let's look at these last two. Are you going to stand there and be obnoxious, or are you going to leave?
I'm waiting for something to print.
Oh,
I'm waiting
okay.
for my homework to print.
Oh, you're waiting. Sorry. My daughter's sitting here dancing in front of the computer. I should switch the camera onto her. Okay. Oh, here they come. Oh. All right. Exciting week at the Ballard House. We have to get the pool replastered. Okay. It's an expensive week at the Ballard House. All right. Let's keep going. We're going to do the formula for the average rate of change. Doesn't that sound exciting? I know Ellie's excited about it because guess what? She already knows the formula for average rate of change. Did you know that, Ellie? And it's not because you took this class when you were in my belly. It's because the average rate of change is just the slope formula. Ellie, do you know the slope formula? Could you tell it to us?
Y equals M plus B.
No. That's slope.
Intercept.
That's slope intercept. What's the formula for the slope of a line? Rise over run. Okay, is there more to it than that?
No, delta Y over delta X.
Delta, well, could you go a little further?
Really?
Y what?
Y sub 2 minus Y sub 2.
Y does Y sub
Oh, minus Y sub 1.
over.
X sub 2 minus Y sub 1.
Does everyone think that it's fun to have a math teacher for a mom?
It's not.
She just said I'm not a fun mom.
No, I said you're not a fun math teacher.
Oh, I'm not a fun math teacher, Mom. Apparently, I'm no fun. All right, because when you interrupt Mom's class, you get to participate. All right, here we go. So let's go to here. Okay, we're going to do this example. So the temperature of a classroom is given by T of T, where T is measured in degrees, not confusing at all. Fahrenheit, and T is measured in hours. Values of T are given in the table above. What is the average rate of change? You see how it actually used the words average rate of change? So it's very clear that I am doing slope, okay? Temperature of the room from 0 to 5 hours. We've done this one, right, before. This one comes up in Riemann Sons. It's usually the first problem, right? It's usually the first problem. So average rate of change equals, okay, and I'm going to just do my slope formula. I'm going to pick on these values right here. We've done this before plenty of times. So my y values would be 60 minus 72 over 5 minus 0. So we've got negative 12 over 5. If we put it in decimal, we would get like negative 2.4. We have to label this, okay? So let's label it. What do you guys think the label is going to be, given that we just did a derivative? Think about what's over here. Can you tell me in the chat, what do you think the label is going to be? Usually it's like something per something, right? Okay. Would we square it this time? Because it's not a rate, it's not a second derivative, right? It's a first derivative. Do you want to revise our answers, you guys? Ah, that's looking a little bit better. Fahrenheit per hour, right? It's always your Y. Oh, that's good. It's always your Y divided by your X, right? Just like Ellie was just saying a minute ago, changing Y over changing X, right? So we're going to say degrees Fahrenheit per hour. All right, we're going to do one more. Okay. So if R of t equals the square root of sine of t plus 2 represents the rate people are entering the ocean at Oceanside Beach in hundreds of people per minute, find 1/3 be from 2 to 5 R of t dt using correct units. In what does this answer represent? So this is a very typical of what you will see on a free response on the AP test. They will give us a function. They already told us this part. We have to calculate it, and then we have to interpret the answer. So the interpret the answer part is hard, but once you start recognizing these, it should be an easy interpret the answer, easy points to pick up. All right, so the first thing I'm going to do is just set up the 1/3, the integral from 2 to 5 of R of t dt. Because they gave this to me, I'm not going to make a mistake writing that down. I hopefully will type it into my calculator correctly. So that's what we're going to do first, is let's get that typed into F1. Okay. So I'm going to go doc B. I'm going to come here to F1. And we're going to type in square root. So control square root trig sine of x. And then plus 2. It doesn't matter if you have a capital X or a lowercase x. I don't know why mine's all of a sudden going capital, but it is. And then I'm going to hit enter. Make sure that your plus 2 is under the root symbol. And again, it doesn't matter if we can see it or not. We really don't care. We're going to go back here to the calculator page. Control divide 1/3. And then shift plus. I'm going to go 2 to 5. I'm going to go var f1 of x dx. And then hit enter. Okay. Type in the chat what you get as your answer. Type in the chat what you get as your answer when you're done, and making sure we're all typing it in right. Okay. You can do the same thing in Desmos. So if you don't have your graphing calculator or you're not somewhere you have it, you can type it into Desmos just the way it looks. Okay. You start typing int for integral. All right, it looks like we're on the right track, hopefully here. I'm going to hit enter. Is it not working? Uh-oh, something's wrong. Uh-oh, are your calculators in degrees or radians, everybody? Either I typed it wrong or you typed it wrong. One of the two. Mine didn't come out the same as yours. What did we do wrong? Let's see. It looks like I typed mine right. Double check because everybody seems to have gotten the same thing. Can you guys double check your calculators and make sure they're in radian mode for me? So you come over here to menu. Nope, we're going to go home first. Go to home and then go to settings and then go to document settings. Maybe mine's in there. No, mine's in radian mode. Make sure you're in radian mode and hit make default and click OK. So I don't know why we're not matching. Let's see. Make sure. Oh, no, I got the same thing last year as I just got now. You got the same as me? Okay. Oh, Robert's was in degrees. Okay. So Robert, get yours fixed. Okay, thank you, Cynthia, for confirming that. All right, so we're always, and put it in degrees and leave it there, or sorry, radians and leave it there. We don't work in degrees in calculus, okay? So we've got this guy as our answer, just 1.306. Let me see if it'll let me cheat on that a little bit. There we go. Okay, now the catch is we still have to deal with using correct units, what does this answer represent? So we're going to go back to what does the context of the problem say? So we're going to say 1.306 is, and let's go back to what it says. It says the rate people are entering the ocean, but we know when we had that 1/3, because what that's representing is the 5 minus 2, right? So that is representing, when you see that fraction out front, that means it's average, okay? So we're going to take these words of the problem here, and we're going to put the word average in front of them. So is the average rate people are entering the ocean, okay, at Oceanside Beach. Is that the best one, Oceanside Beach? I know we like Del Mar. From when we go, we don't get to go very often. In hundreds of people per minute. Look at what it's measured in. So you want to keep that in hundreds. In hundreds of people per minute. I'm not really a big beach person because I do not like sand. I'm happy to be like on a lake in the water. I'm good on a boat like that, but no beach. Too messy. All right. That's it for this piece of the lesson today, okay? So what you guys, I'll put it there a minute and leave it there another minute, is you need to go watch. There's the homework is based off of that lesson, okay? I'm not going to put out a homework assignment based off the other lesson until we completely finish it. So it might be like Friday before we end up getting to that, all right, for the 8.1a. I kind of snuck it in there because it didn't really go anywhere, but I know we needed to do it because we did some of the words, the equation ones earlier in the year, and now we got to put the integrals in it, and it didn't really fit anywhere good. So I added it in there today. All right. Okay, let's do the joke of the day because that's the last thing we have left to do, right? Uh-oh, it didn't present. Hang on. Gotta love it when Google does that. Okay.
Hello, everybody, and it's time for the next joke of the day. Why should you never mention the number 288? Because it's too gross. And I'll be here all week
gross, or
because
88
I live
is a gross
here.
or something.
Bye-bye.
All right. That's all I've got for you guys today. I will see you again on Wednesday. Make sure you get your asynchronous work done, okay? So have a great day, everybody. Bye, Sophia. Bye, Brianna.
Excuse me?
Yeah,
Ms.
what's
Ballard?
up,
I had a question about the calculator.
Yeah.
So mine says error. It doesn't actually let me use it.
It doesn't let you use it?
Yeah, here I'm plugging it in right now so I'm gonna turn my camera on so you can see what it says.
Yeah, let's see what we can figure it out, okay?
Okay.
Is that something new that's happening, or has it always been that way?
It's always been like that. I just haven't really
Mess with it.
mess with it. But I want to use the calculator. I found myself in situations where I want to use it. So here. Okay, I'm turning my camera on now. Okay, so
Oh
right
boy.
here.
It stops at that spot.
Yeah, it's just halfway through. And
System error.
right here, system error. Yeah.
Okay. Probably so on the let's try one thing. If we can't get it to work, you can probably go to school and trade it out.
Okay.
So flip the calculator over to the back. Yeah, okay, and on the back there's a little tiny dot that says reset. Do you see that button right there?
Yeah.
Okay,
Yeah.
take a pencil or a pen and jam it in there.
Okay.
And then see if it'll reset. It might not go beyond that system error though. We might have to like reinstall the operating system. And that's not something you can do from your Chromebook. I know that. And I don't know if we'll be able to get it redone from what do you call it? The
Okay. So do I have to hold it or do I just press it once?
push it in, hold it for like count to like 3 and then let go.
1, 2,
Let's see if that resets
3.
it.
Okay.
Oh, it still did the same thing. Okay. So
Yeah.
the best thing we can probably have you do, because the other thing is you can try to pop the batteries out and redo all that, but that's kind of a big mess. It's probably easier if you can get yourself down to school and go trade it out.
Go get that.
Okay.
And then tell the Darla, the librarian, tell her that you talked to me and have her put a sticky note on it that one was giving a system error, and I will take care of it.
Okay.
Sound good?
Yep. Sounds good.
Okay. Temporarily, you can use Desmos to do them. Okay.
Okay.
Yeah, you did.
Yeah.
All right.
All right. Okay. That's all for me.
All right.
Thank you.
You're welcome, kiddo.
Okay. You have a nice day.
You too.